tahu. So this one is on sufficient statistic. So in order for you to understand the concept for sufficient statistic, you have to know, and then you have to know how to prove or how to derive whether you have the unbiased estimator or not. Okay, and then you have to know clearly how to find your theta head normally using MLE lah, using MLE. Okay, so if we refer to the term for sufficiency, okay, sufficiency maksudnya cukup ke tidak, sufficiency. So it is also a property of an estimator, okay, relates to the amount of information that contains, okay, it contains, okay. For example, let's say if you refer to your notes here, I already explained in detail, okay. So let's say instead of we have observation, we list all that observation. For example, you have x1, x2, xn. So normally what we did is we just summarize and then give the value in terms of sample mean, sample variance, and also sample standard deviation. Okay, biasanya kita akan ungkapkan dia punya maklumat tu dalam bentuk mean, sample variance ataupun sample standard deviation, and ada term be sample proportion. Okay, okay. So again, the term for statistics. So when we mention about statistic, it is a function of your random sample. For example, in this case, let's say we denote a statistic, we denote using T, we use symbol T. So where T is equals to U, X1, X2, Sn. Maksudnya that term is in terms of function. Okay, so X bar is a function of your random sample, S1, S2, Sn. Your X bar 1 over N summation Si. So the same thing as your S square, your sample variance. So it is also a statistic which is a function of the random sample. Okay, so that's mean your statistic T in here is in the form of data reduction. Maksudnya kalau let's say kita ada observation yang banyak, kita ada n observation, and then now kita reduce, kita just summarize, and then we just one value, which is your x bar or your s square. So that's why we call this one your T is a form of data reduction. So thus in here, statistician looks for ways of reducing a set of data so that this data can be more easily understood without losing the meaning, okay, situated with the entire set of your observation. Okay, maksudnya kalau let's say kita dah ada x bar, kita ada s square tu, kalau boleh kita tak nak, even though kita tak listkan all observation, we just give you x bar, tapi kalau boleh, make sure your x bar tu is called as sufficient statistic bila kita tak lose dia punya information. Okay, itu maksud sufficiency ni. Okay, one of the property in your property for your estimator lah. Okay, we have a detailed definition lah. So we say T is a sufficient statistic if the statistician who knows the value of T here, okay, can do just as good in estimating the unknown parameter data, okay, as the statistician who knows the entire random sample. Okay, kalau kita dah tahu X bar. So kalau let's say that statistician dia tahu dia punya nilai X bar, is the same thing kalau let's say the other statistician just list all the observation. Itu maksud dia. Okay. So then, okay, we have a statistic T, which is a function of your random sample. Is said to be sufficient. Is said to be sufficient for unknown parameter data if we have a conditional distribution. Okay, conditional kau faham kan? Let's say you have conditional probability. That means you have A given B. Gitu. Okay, that means your event B is already occurred. You want to find probability of A given B. So the same thing. Conditional distribution of your x1, x2, Sn given your T. Okay. When we have the conditional distribution of x1, x2, Sn given T does not depend on data for any value of T. Maksudnya kalau kita buat, kalau kita compute the conditional distribution, okay, maksudnya this one lah, probability x1, x2, xn given T. So this conditional probability distribution, when we compute, does not depend on data. So then we call this statistic T is sufficient. Okay, or in other words, given the value of T, maksudnya kita dah bagi nilai T tu apa, we can gain no more knowledge about theta from knowing more about the probability distribution of S1, S2, Sn. Maksudnya, nilai T tu dah ada nilai T tu dah cukup tanpa kita tahu the list of all observation. Okay? So, itu maksud dia punya definition secara roughly lah. Okay? Secara formulanya nanti kita akan tengok. So, maksudnya di sini, you have your T is sufficient statistic. Kalau let's say if we compute your conditional probability distribution, S1, S2, Sn, given your T, kita tahu T berapa, kita compute that conditional probability does not depend upon theta. So, kalau kita tengok secara definition, general definition dia, okay, we have a random sample. Okay, we have your S1, S2, Sn is a random sample. Again, we have size n. Okay, masing-masing kita ada probability function. Okay, probability function fx theta. Okay, again, the same notation lah ya. Theta belong to omega subset to any real values. Okay. So let T is equals to U S1, S2, Sn is your statistic. Okay, kita tahu dia punya PDF apa. Okay, whose PDF? Let's say this is the PDF of your statistic T, G T theta. Okay. Then we can say that T here is a sufficient statistic for theta if and only if kalau kita ada joint probability function, maksudnya fx1 theta, fx2 theta, fxn theta, divide by your PDF here, PDF of T, you get h x1, x2, Sn, and your h here does not depend upon theta. Maksudnya nilai h kamu tak ada nilai theta kat dalam dia punya derivation lah. Maksudnya h, s1, s2, Sn tu tak ada, does not contain theta. So then you can call T as a sufficient statistic. Okay. So it's the same thing. Kalau let's say kita tulis dalam bentuk conditional probability. Okay. So the same thing kamu tulis benda ni sama je. Okay. You have x, x1, x2, Sn given T equals to T. So it's the same thing. You have joint probability function divided by G P theta because your T is your sufficient statistic. Maksudnya kita akan conduct conditional probability distribution. Kalau kita ada the ratio of these two, maksudnya joint probability function divided by your PDF of your sufficient statistic T ni, kita akan dapat dia punya nilai H, S1, S2, Sn. And if your H does not depend upon theta, so that means your T is a sufficient statistic. Okay, itu secara definisi ya. Secara definisi dia punya definition lah. Okay, kita nak tengok macam mana kita nak explain in terms of probability function. Okay. We start with a simple one. Okay, because nanti at the end tu kita akan guna one theorem which is called as factorization theorem. Okay, ni example yang ni saya listkan di sini. I think I already derive in your notes. Dalam modul tu dah ada. Okay. Just kamu follow je apa yang saya cakap. So this one is proving ataupun derivation based on definition. Okay, nanti later on you can solve using either definition or you can solve either using one theorem which is we call as factorization theorem. Okay. So again this one is for Bernoulli trial. The Bernoulli distribution. So Bernoulli distribution that means each of your xi ni. X1 is Bernoulli distribution, X2 is also Bernoulli distribution. Where you have your probability mass function is given as this one, fx theta, theta to the power x, okay, 1 minus theta to the power 1 minus x. Okay. Dia dah bagi kat sini, dia tak tulis find the sufficient statistic. You just write down, show that T equals summation Si is a sufficient statistic. Maksudnya kamu kena prove lah. Macam mana kita nak tunjukkan T equals to summation Si is a sufficient statistic. Okay, we use the concept for conditional probability. Okay. Sebelum kita dengan conditional probability itu, so this one, ini dia punya formula dia. Okay, you have, let's write down. We have your fx1, x2, Sn given T. And then kalau kita expand, dia akan, this one, you punya joint probability function dengan dia punya PDF of your T distributed. T, which is your sufficient statistic PDF of your T. So we start with the same thing, macam likelihood function. Okay. So you have, again, your random sample are independent because we have Bernoulli trials. So Bernoulli trials are independent variable. So the same thing goes for binomial distribution, and binomial is also independent. Okay, independent, that means you can multiply once we have the product. So let's say if you have Bernoulli distribution, maksudnya kat sini. So maksudnya let's say if you have this one, okay, I equals to 1 up to n, you have fxi theta. Okay, so you have this one theta is 1 minus theta, 1 minus x is 1. So you have theta x2, 1 minus theta, 1 minus x2, sampailah kamu ada theta xn, 1 minus theta, 1 minus xn. Okay. So by independence, you can multiply the probability. Okay, now kita simplify. So the same thing. You have theta, x1, x2, xn. Okay, so theta sama. So kuasa tu kita akan jadi tambah. So the same thing, 1 minus theta. You have n terms. So here you will have theta to the power summation xi. 1 minus theta, n minus summation xi. So first, make sure your likelihood function is correct. Okay, kalau kamu punya likelihood function kat sini dah sana, dia akan effect yang lain. Memang tak ada masalah lah. So that means you need to sure that your punya joint distribution ni is correct lah cara kamu expand semua tu. So you have theta summation xi, 1 minus theta to the power n minus summation xi. Okay. So now kita dah ada, kita nak construct dia punya conditional probability distribution. Okay. Kalau kita tengok dia punya, kalau kita ada this one, you have fx1, x2, xn given t equals to t, so you have this formula. Yeah? So it's the same thing. If you have fx1, x2, xn, t theta, maksudnya inilah. Yeah? Yang bahagian atas tu. You will have probability x1 equals to x1, x2 equals to x2, xn equals to xn, and t equals to t. The same thing, so kalau kita relate lah. A given B. So it's the same thing. You have A intersect with B divided by probability of B. So kita apply the same concept for conditional. Basic conditional probability you already learned. Okay. So that's mean you have x1 equals x1, x2, x2, xn, xn, and then you have n t equals to t. Okay. But your t is equals to summation xi. Maksudnya setiap value lah x1 plus x2 plus xn. Okay. It also can be simplified by writing this one. Benda yang sama. So you have your S1, x1, x2, x2, but your Sn here, we just write T minus summation xi, I equals to 1 up to n minus 1. Okay, sebab T kamu ni, apa tu? Summation xi, I equals to 1 up to n. Yang kita minus ni adalah I equals to 1 up to n minus 1. So dia akan dapat balik Sn lah actually. So it's the same thing. Tapi kita just write up to n xn minus 1, you have small xn minus 1, and then you have your Sn, you can write down as t minus summation I equals to 1 up to n minus 1 xi. Okay, benda yang sama. Boleh faham ya kat sini? Okay. So now, okay. So since the random sample are independent, so again, we can multiply the probability. So you have probability x1 equals to s1, x2 equals to s2, and so on. So ini kalau kita tulis macam ni lah bentuk ni. So you have theta s1, 1 minus theta, 1 minus s1, and so on. Cuma untuk xn ni kita ada theta, yes, kita ada theta to the power n. Tapi sn kita kan kita replace t minus summation xi where your I equals to 1 up to n minus 1. Kalau macam ni, case dia kamu kena tulis lah. I kamu daripada mana ke mana. Kalau kamu tulis yang macam ni je without your index kat bawah tu, maksudnya kita tak tahu I kamu tu daripada I equals to 1 up to n ataupun I equals to 1 up to n minus 1. So make sure you write this one. So you have equals to 1 up to n minus 1. Okay. And then 1 minus theta. So again, kita 1 minus theta you have 1 for the last one. 1 minus Sn. So the same thing, 1 minus T minus summation Xi. I equals to 1 up to n minus 1. So ringkaskan, simplify. Okay, you have theta x1 plus x2 plus x3 sampailah plus you have the last value tu. Okay. So dia akan cancel out kan dengan yang ni. Okay, so that's why dia akan tinggal theta to the power t. Okay, kalau kamu ada x1, x2 sampai kamu ada xn minus 1. So dia akan cancel out dengan minus summation si, I equals to 1 up to n minus 1. So that's why yang the last value is your theta to the power t saja. So the same thing yang ni, 1 minus theta ni. Kamu ada 1, 1, 1, 1. So kamu ada n terms lah. N terms. So minus x1 plus minus x2 plus minus xn minus 1. So dia akan cancel out dengan this one. Okay. So yang tinggal adalah n minus t. Okay. Sebab kita ada n terms. Same thing. Jadi kamu ada n minus t minus summation si tu. Si kamu tu dah cancel out dengan yang kat luar tu lah. S1, S2, xn minus 1. So you have this one. Bila kita dapatkan dia punya joint probability function. Okay. So now kita dividekan dengan dia punya PDF of your sufficient, of your T. PDF of your T. Kita tak cakap lagi dia ada sufficient statistic. You want to show that. Okay. So kita divide dengan PDF of T. So now T is equals to summation Xi. Okay. So T is equal to summation Xi. So again, kamu punya S1, S2, Sn individually is coming from Bernoulli distribution. But when you have your summation, it will become binomial distribution. Okay, binomial distribution. Sebab kita tak bagi what is the PDF of this one. PDF of your T. Maksudnya kamu kena faham lah. Ialah basic knowledge lah maksudnya. T equals to summation Si, dia akan jadi binomial distribution. Kalau binomial kan kamu ada normally lah. Kamu ada n. Macam tu di mana n choose x, okay, p to the power x, and then you have 1 minus p, n minus x. That one. So the same thing. Now your t is equal to summation si. So kita akan ada n choose t, theta to the power t, 1 minus theta, n minus t. Where your t is equal to 0 up to n. Okay, because it's already coming as binomial distribution. Okay, now kita masuk ke balik, substitute balik. Kita dah ada joint probability function tadi. Dividekan dengan GP theta ni. Okay, so you can have cancel out here. So you have this one. Okay, ini yang kamu punya nilai H tadi tu. H, S1, X2, Xn. So now your H does not depend upon the parameter theta. Tak ada nilai parameter theta dalam ni. So by definition, your T is equal to summation Si is a sufficient statistic. Itu cara dia punya proof dia. Di mana kita applykan conditional probability distribution. Yeah. Okay, kita apply conditional probability distribution. Basic lah, this one. Okay, this one. Okay. Joint probability function. Okay, so you have this one. Okay, so kita replacekan T minus sebagai summation Si. I equals to 1 up to n minus 1. So expandkan dulu. And then simplify. You already get theta to the power T. 1 minus T to the power n minus T. Okay, sebab kita ada n term. Now, kita dapatkan apa PDF for T. Sebab kita dah tahu T is equals to summation Si. So once it's summation Si, it becomes binomial distribution. So ini dia punya PDF dia. Okay, and then you divide lah. Divide. So second, this is your age. Age does not depend upon the parameter theta. So by definition, tulis sikit lah. By definition, your T equals to summation Si is a sufficient statistic.